Blue.
Nini? Ilikuja hivyo?
Bana. Mtulie. It's another fine morning that we are going to start our lesson, and we shall go through the paper that was sent to you. And I also share that paper on the screen. And because you had the paper for 2 weeks, you have familiarized yourselves with the questions. So I'll go through the questions and give the
Madam
answer. Yes?
Mr. Malwa
Yes.
here.
Yes, Mr.
Yeah.
Wamadwa.
Yeah, we're getting you very clearly.
Yes.
Maybe we just, the students were expecting mathematics. Maybe it's good we make it clear to them that they'll have mathematics at 11 after chemistry. So for now, they
Yes.
do chemistry, then it will be followed by mathematics.
Oh, okay.
So you can go on with your lesson.
It's fine. I'll tell them.
Yeah, you just go on. You are clear.
Okay. I continue with the question. Question 1. The question is got from the topic of rate of equation that was part of the assignment. And we have to have arrows like that. Then you can see one arrow is pointing to the forward, the other one backward. Illustrating that there are two reactions that are taking place, the forward one and the backward reaction. And when the arrows are half, you can see that is an arrow that is half. It shows that the two reactions, that is the forward one to form carbon 2 oxide and hydrogen, and the backward one to form they are taking place simultaneously and at the same rate, at the same speed. From the topic of energy changes, then you can be able to see that from the reactant, the energy level diagram that is drawn, it is for the forward reaction, where the carbon and the water, the gaseous water, are the reactants. And the product is carbon 2 oxide and hydrogen, now from the energy level diagram. And that energy level diagram illustrates a type of a reaction that is exothermic, because the reactants, they have higher energy. When you look on the y-axis, the reactants are of high energy, and then the heat is lost, and the products have got less energy. So that is an exothermic reaction where the products have less heat energy than the reactants. We can answer the question, what would be the effect of the position of the equilibrium if the temperature is increased? Explain. Looking at the energy level diagram, that reaction does not require energy. It does not require heat energy. It is losing the heat as the reaction progresses. So increasing the temperature is going to stop, or it is going to make the reaction to reverse to the opposite direction. So increasing the temperature will not favor the forward reaction because the forward reaction is exothermic. Rather, it will favor the backward reaction. Reason, the forward reaction is an exothermic reaction that takes place by losing heat. So it does not require heat because it is an exothermic reaction. Then we move down to the other question, why a molecule of water.
Cha,
Yes.
I have a question.
Yes.
On that question, do you use the one shifting to the right? Yeah, either like such answers. Maybe the position of equilibrium shifts to the left, not favoring the forward reaction, favoring the backward reaction. That one. Can you explain that one?
Okay. The question is asking about the position of the equilibrium. So I've said the position of the equilibrium is going to shift to the left, backward, because
Yeah.
increasing the temperature will favor the backward reaction. So the equilibrium is going to shift to the left. In terms of the reaction that will be favored, the backward reaction will be favored. Because the backward reaction the forward reaction does not require heat. So that one will not be favored. The one that will be favored is the backward one. In terms of the yield, more of the carbon and water will be formed.
Yeah.
All right. Okay, I proceed. I have just given that answer like that. And it is accurate that way. Now, hiyo swali ingine, that is it is a different question. Yes.
Before you continue, I'd like to ask, what does the question mean by saying position of equilibrium? What does the question mean?
I can see most of you are really asking. That question is on the topic of rate of reaction, and we have not covered. But I said I will just answer the question for the sake of those maybe who have interacted with the topic. But
Okay.
I said a state of equilibrium. The way the equation is, it shows a state of equilibrium. You see, the reversible reactions that we have learned earlier, we use a complete arrow to show the forward reaction and a complete arrow to show the backward reaction. But this type of an equation where the arrows are halved, they illustrate that the forward reaction and the backward reaction are taking place at the same rate. And at that way, we say that the equation is at equilibrium. At equilibrium, where the forward and the backward reactions are taking place at the same rate.
Okay.
But we shall further discuss it when we open. Is that fine?
Okay. Thank you.
Right. Okay. Just allow me to continue. And I said we shall embark more on that when we shall, because we'll go through the topic. Explain why a molecule of water can form a bond with hydrogen hydrogen ion to form hydroxonium. That one is more of a question on acid bases, but I will still answer because right now where we are, we should be able maybe to answer any question. Hydroxonium is an ion H3O with a charge of +1. How is it formed? It is formed when hydrogen ions are in water. That is, if the solution is acidic, because an acidic solution has got hydrogen ions. Now, those hydrogen ions in water, they are positively charged and they are too small, so they will be fed to interact with the water. And in that case, the word proton is a charged particle. We know a proton. The H2O now gains the hydrogen ions, which is referred to as a proton. And so what will be formed will be H2O plus hydrogen ion. Then the whole of it will be H3O and a positive charge. So hydroxonium, also called hydronium, is formed when water gains the hydrogen ions, which is also a proton. I move to the next question. The next question is a hydrocarbon contain 80% of carbon by mass, given that 1 decimeter cubed of the compound at STP has a mass of 1.34 grams. Calculate the molecular formula of the compound. Then we are given the molar gas volume. Molar gas volume means 1 mole occupies 22.4 decimeter cubed. And then we are given the REMs. Carbon is 12, hydrogen is 1. Calculating, we start from what is known. 1 decimeter cubed will contain how many moles? 22.4 decimeter cubed will be contained by 1 mole. So 1 mole is 22.4 decimeter cubed. How about 1 decimeter cubed? 1 decimeter cubed will be 1 over 22.4 times 1. There you get 0.044642857 moles. Then from the question, 1 decimeter cubed has a mass of 1.34. Meaning the moles that we have got are in 1.34 grams or 1.34 grams are the grams from the moles that we have calculated up there. So the other question will be, what about 1 mole? What about 1 mole? 1 mole will have what mass? So when we get the 1 mole is equals to RMM. 1 mole
excuse me, madam.
1 mole is equals to the RMM. So in that case, 0.04642.857 are in 134. What about 1 mole? So 1 mole will be 1 over the number of moles times 1.34. And when I did my calculation, I got that 1.16. 30.16. We are getting the molecular formula mass, which is equivalent to 1 mole. So as long as you're able to get the moles and the mass, those moles are in that mass. What about in 1 mole? Then you'll be able to get the RMM. The other question number 3.
Excuse me, teacher.
Yes.
So what was the answer for number 1B? I didn't understood.
1B.
Yes.
1B ni swali gani? Uliza swali tu direct.
Explain why a molecule of water can form a bond with hydrogen ion to form hydroxonium ion.
That one I had explained about hydrogen ions. The hydrogen ion is positively charged. The hydrogen ion is positively charged. Because we need to understand, first of all, how is hydroxonium formed? It is formed when water molecule combine with hydrogen ion to form the hydroxonium. So why does that happen? Because hydrogen ions are positively charged. And when hydrogen ions are in the water will gain a proton. And I said the hydrogen ion is equals to a proton particle. So how is it formed? The water gain a proton. The water gain a proton and become H3 plus. That question is got from acid bases, although we have not learned also. That is why maybe we are not getting it very clearly, where we talk about the Ahearn's theory, where hydrogen is the proton donor. And then we say acid is a proton donor and base is a proton acceptor. So in this case, when I say water gains a proton, then we are referring to the hydrogen ion as a proton. The water gains a proton, into bracket, hydrogen ion, to form the hydroxonium. You get it? The one who is asking.
Yes.
Okay. Na nimesema hiyo iko kwa topic ya acid, bases and salt. We shall also review it further when we'll be looking on that topic.
Okay.
Writing chemical equations for the red oxide and sodium hydroxide. The property that is being tested in that question is the amphoterism of lead 2 oxide. It's amphoteric nature. It can react with a base and it can also react with an acid. When it reacts with the base, sodium hydroxide, you are writing the equation PbO plus NaOH. PbO plus NaOH. The product will be sodium plumbate. Sodium plumbate and water. Sodium plumbate is Na2PbO2. Sodium plumbate and water. I said sodium plumbate is Na2PbO2. O2. Then plus water. Then to balance that equation, you put a 2 in front of sodium hydroxide. The one for dilute hydrochloric acid.
Excuse me, teacher.
Yes. Go on.
And what is the answer to number 2?
Number 2, I said it is 30.16. And it is like we are in question 3. Now we are in question 3. Or you joined later. Okay. Question 3. I've already given the first answer for Roman number 1. I hope you are following. And I said what is being tested is amphotericin of lead-2 oxide. It can react with both base of Roman number 1 and acid of Roman number 2. How does it react with base? PbO plus NOH. The product is Na2 PbO2 plus water. Then you put a 2 in front of sodium hydroxide. Then Roman number 2. That is a neutralization reaction also. In that reaction, now the lead oxide reacting with hydrochloric acid. Lead oxide this time is behaving as a what? As a base. PbO plus HCl. The answer will be PbL2 plus water. That is salt and water. PbCl2 plus water. Then you put a 2 in front of HCl. In Roman number 1, the lead oxide is behaving as a weak acid. In Roman number 2, the lead oxide is behaving as a base. So that question is testing on amphotericin of lead oxide. Other oxides that will behave the same are aluminium oxide and zinc oxide. They are also amphoteric oxides. Aluminium oxide and zinc oxide. We go to the other question. Question B. State the property of lead-2 oxide demonstrated above. The property I have already said it is amphotericin. Amphotericin property. So the property is amphotericin. The oxide is amphoteric. The property is amphotericin. The oxide is amphoteric oxide. And other examples of amphoteric oxides are aluminium oxide and zinc oxide. We move to the next question. Sulfur 4 oxide react with the potassium dichromate as the equation you can see.
Sorry. I was just asking, can you please repeat the equation between lead oxide and sodium hydroxide, please?
PbO for lead oxide, NaOH for sodium hydroxide. Then you put an arrow. The product is Na2 PbO2. I said Na2 PbO2, then plus H2O. And then a 2 in front of sodium hydroxide to balance the equation. Before he interrupted, then we're in question number 4. You can see the equation. That equation, the SO2 gas is bubbled in acidified potassium dichromate 6. Acidified potassium dichromate 6 is illustrated by that hydrogen ion plus hydrogen ion. Hydrogen ion is showing that the dichromate 6 has been acidified. And the reason for acidifying this oxidizing agent is to ensure that there is complete reduction from potassium dichromate 6, CrO7, to chromium 3 ions. Then the other product is the sulfate ions, and the other product is water. In that type of a reaction, as you can see, the SO3 has become SO4. So that is oxidation. The dichromate 6 plus 6 has become plus 3 on the product side. That is reduction. Therefore, that is a redox reaction. What is the oxidation number of the chromium ion in Cr2O7 2 negative? Hiyo swali tunaweza ijibu tu literally by saying we know that potassium dichromate 6, the name is given from the oxidation number. So directly, hata kama hujasoma oxidation number, you can just say plus 6 because it is called dichromate 6. And the name of a compound is given using the oxidation number. When we say iron 2 oxide, the oxidation number of iron is 2. Iron 2 sulfate, the oxidation number of iron is 2. Potassium dichromate 6, the oxidation number of the chromium there is plus 6. Potassium manganate 7. The manganate in that potassium manganate 7 is 7. But we can calculate. Kama umesoma electrochemistry, we can calculate how that to get that plus 6 by saying that the oxidation number of any molecule is 0. The oxidation number of any compound, tuseme kama sodium chloride, it is 0. How? Sodium in the sodium chloride is plus 1. Chloride in that sodium chloride is negative 2. So when you add plus 1 minus 1, you get 0. So the total oxidation number of compound is 0. Looking at what we are given an ion because that is Cr2O7 2 negative. That one is a charged particle. So a charged particle, the oxidation number of the whole of that dichromate ion is equals to the overall charge. What is the overall charge? Negative 2. To mean that if you take the oxidation number of Cr you add the oxidation number of oxygen, their total oxidation number should be -2. And because we are calculating the one for chromium, then we are going to write how many chromium are there? 2. So 2 Cr plus, what is the oxidation number of oxygen? Hiyo tunajua tu ni -2. Because oxygen gain 2 electrons and its ion is written as O2 negative. So the oxidation number of oxygen there is -2. And how many are they? There are 7. So we say plus -2 times 7 is equals to -2. Then 2Cr is -2 times 4 itakuwa -14. So we take it to the other side. These are simple maths. It will be -2 plus -2 plus what? Plus 14. 2Cr will be plus 14 minus 2. 2Cr is plus 12. Then Cr is plus 6. I've said we keep on saying dichromate 6. Now we have seen how to get the 6, meaning the oxidation number is plus 6. The oxidation number of chromium is plus 6 in that compound. More practice on how to calculate the oxidation number will be when we'll be embarking on the topic of electrochemistry. So I can proceed. State and explain the observation made in the above reaction. At least for that one, we can be able to see that the dichromate color is orange and the chromium 3 is green. The color of the solution will change from orange to green. The reason for that, it is because the dichromate 6 will be reduced to chromium 3. It will be reduced to chromium 3. I move to the other question. Nitrogen 1 oxide is a colorless gas with a pleasant smell and cause insensitivity when inhaled, but it is not reactive at room temperature. However, it rewrites a glowing splint. Explain why the gas rewrites a glowing splint. In that question, any gas that contains oxygen, tuseme carbon 4 oxide, nitrogen 4 oxide, nitrogen 1 oxide, nitrogen 2 oxide, when they are heated, they decompose, whether they support combustion or not. When they are heated, they decompose. And when they decompose now, they release the oxygen. And that oxygen is now, will now support the combustion. So like in that case, if the glowing splint is hot, the heat given out is the one that is going to decompose the nitrogen 1 oxide into nitrogen and oxygen. Then the oxygen given out will rewrite the glowing splint. The same thing will happen if you put even hot magnesium in a gas jar containing even carbon 4 oxide or even nitrogen 1 oxide or nitrogen 2 oxide or nitrogen 4 oxide. That heat decomposes the gas into oxygen and the other part And now that oxygen will support combustion. So as long as there is heat and the gas contains oxygen, the heat decomposes the gas and give out the oxygen that support combustion. So what is the answer? The heat decomposes nitrogen 1 oxide to nitrogen and oxygen. And oxygen rewrite the growing splint. Hiyo swali ingine. We move to the other question. Tuendelee na hiyo swali ingine unless kuna mtu ako na swali. We continue with the other question. We continue with the other question. I said question down there. Can be repeated with nitrogen 1 oxide. It can also be replaced with carbon 4 oxide, nitrogen 2 oxide, or nitrogen 4 oxide. Then one of the uses of nitric 5 acid is purification of metals, e.g. gold. Explain why nitric 5 acid is used in purifying metals. That question on purification, it is all about the ability of the acid to react with that impurity. So what is the impurity here? The impurity can be an oxide. The metal has been coated with an oxide. And because the acid react with the oxide to form now a solution of that acid. So then we have the metal oxide reacting with the nitric 5 acid to form a nitrate solution. And then the other product, of course, is going to be water. And so the question asks why the nitric 5 acid is used to purify metals. Because the acid react with the oxide, can be able to react with the oxide because acid react with the oxide to form salt and water. It will be used like for cleaning metal surfaces. Let's say a metal surface is made of iron and it has rusted. A dilute acid like hydrochloric acid can also be used to remove the rust because the rust is an oxide and the acid will react with the oxide to form salt and water. So as long as the acid can react with the oxide, it can also react with the carbonate if maybe the impurity was a carbonate or it was an oxide. Then the acid will react with those impurities and dissolve them. And then we form a solution that has got the ions of those metals, come if it is gold or iron, which now is extracted through electrolysis, or it is purified further using electrolysis. Then we have got Another question down there, still on an acid. A sample of a salt in a test tube to a sample of a salt in a test tube, add freshly prepared iron 2 sulfate, slant the test tube slowly, add concentrated sulfuric 6 acid. Which ion does this test aim to confirm? That process is the brown ring test. In the brown ring test, a nitrate is put in a nitrate solution is put in a test tube, and it is added freshly prepared iron 2 sulfate solution. Then it is tilted and slowly concentrated sulfuric 6 acid is ran at the wall of the test tube. Then it is made to stay upright, so that the concentrated sulfuric 6 acid, because it is denser, will settle at the bottom. And then this mixture of the iron sulfate and the soluble nitrate, they come on the top. And then there is a reaction that happens. The first one that will happen will be the iron 2 sulfate. The iron 2 sulfate on the lower layer, on the upper layer, will react with the sulfuric 6 acid on the lower layer, of course, at the top of the layer. That is where the reaction will take place, because that is where the two reactants are. The iron 2 sulfate is on the upper side, and then the acid is on the lower side. So the reaction will take place at the layer. The reaction that will take place, iron 2 sulfate react with nitric, will react with the sulfuric 6 acid to form the iron 2 sulfate, will be reacted the iron 2 sulfate will be reacted on by the nitrogen 2 oxide that was formed in the reaction to form iron 2 sulfate, combination of iron 2 sulfate and nitrogen 2 oxide, which is called nitroso iron 2 sulfate. Rudisha hiyo swali ya juu kidogo ndio tuimalizie vizuri. Hiyo ya 5, question 5. Question number 5. Question number 5. We are not done with question number 5. I have said that the ions that are being tested there are nitrate ions. And what you'll be seeing will be a brown ring that will be formed around where the layer is. And the name of that brown ring will be FeSO4 dot NO. That is nitroso iron 2 sulfate. Now we can proceed to the other question. We can proceed to question number 6. Move on to the other question, question number 6. We can move on to question number 6. Question number 6. Question number 6. Meanwhile, if there is a question, you can ask as we proceed. Now we are on question number 6.
Excuse me, Chair.
Yes.
I didn't quite understand when you were talking about the two reactions that will take place when you're carrying out the brown ring test.
You did not get it correctly, eh?
Yes,
Okay.
the two
I
equations.
repeat, I can repeat it, it's fine. In the mixture has got iron 2 sulfate. It has got concentrated sulfuric 6 acid, and there is now the nitrate. Because I have said it is testing for nitrate. So we can take an example of the nitrate, like to be sodium nitrate, like that. So the first reaction that takes place would be the nitrate. The nitrate now, like sodium nitrate, we take sodium nitrate, react with sulfuric 6 acid, and the product that we are going to get, one of the products that we get is nitric 5 acid. Then the other product we get will be sodium hydrogen sulfate. If you recall very well, that is how we make nitric 5 acid in the laboratory, by reacting a nitrate and concentrated sulfuric 6 acid. You remember that, eh? So that will be the first thing that will happen. The nitrate will react with the sulfuric 6 acid to get nitric 5 acid. So of our interest is now the nitric 5 acid that I said will react with the iron 2 sulfate to form I hope you are following, to form
Yes.
iron 3 sulfate, nitrogen 2 oxide, and water. Iron 2 sulfate plus nitric 5 acid, you get iron 3 sulfate, nitrogen 2 oxide, and water. An NB there. That reaction can only take place in presence of sulfuric 6 acid, which is already there in the test tube. So when we are writing the equation, there must be plus sulfuric 6 acid. But in this case, we know that it is already there in the test tube. Now, how does the brown ring now, how does the brown ring now form? Now I'm on the third equation. The nitrogen 2 oxide that has been formed is going to combine with the unreacted iron 2 sulfate to form nitroso iron 2 sulfate. I write the equation FeSO4 plus NO. The product will be FeSO4 dot NO. Now that is the brown ring. You have written the three equations, eh?
Yes.
not to even the others. So that is what basically happens. And if you look at those equations that we have written, the first one, we learned it when we are learning on how to make nitric 5 acid in the laboratory, isn't it? Reacting a
Yes.
nitrate with an acid. Once you
Yes.
get the nitric 5 acid, if you react nitric 5 acid with iron 2 sulfate, the product are normally iron 3 sulfate and nitrogen 2. Nitrogen 2. So nitrogen 2 oxide that was formed there will react with the unreacted iron 2 sulfate to form iron 2 sulfate dot NO. That is nitroso iron 2 sulfate. Now, which is the ring that form the ring, the brown ring. Ni sawa sawa, eh? I
Yes.
proceed.
Thank you.
The question number 6, that apparatus is the one that is used to make the nitric 5 acid, just what I've explained. That it is called a retort flask. It is used to prepare nitric 5 acid in the laboratory. Reason, it is a special glass that is very hard. It is a special glass that is very hard. And it is specifically for making nitric 5 acid because it is highly corrosive. And the hard glass is to withstand the corrosiveness of nitric 5 acid that is being formed there, and also the concentrated sulfuric 6 acid that is used in making it. It is a hard special glass that resists corrosion of the corrosive nitric 5 acid. So naweza rudia, the retort glass is used in preparing nitric 5 acid in the laboratory, which is prepared by reacting a nitrate, maybe of potassium or nitrate, or potassium or sodium, being reacted with concentrated sulfuric 6 acid, and the products will be the nitric 5 acid itself plus a hydrogen salt, that is sodium hydrogen sulfate or potassium hydrogen sulfate. In that reaction, the salt, a normal salt, is not formed because the temperatures of the conditions of the laboratory cannot be hot enough to form as a normal salt. So an acid salt is formed, sodium hydrogen sulfate. Kama umetumia potassium hydrogen sulfate. On the same reaction, there is a property of concentrated sulfuric 6 acid that we run there. Why is it used? Because it is less volatile, and so it will be able to displace. It is less volatile. So when the two are in the flask, that is sulfuric 6 acid and nitric 5 acid, the concentrated sulfuric 6 acid displaces the more volatile nitric 5 acid from that solution. So they are able to be separated because concentrated sulfuric 6 acid is less volatile. The more volatile nitric 5 acid now will vaporize and form HNO3 fumes that are later condensed using tap water, and now form the HNO3 liquid. Hiyo swali ingine tuachane nayo. Hiyo sitaelezea because it has got so many new concepts. Tutasoma kwa electrochemistry. We move to the other question. Tuende hiyo swali ingine 7. 7 tumesoma. We move to question 8, sorry. Question 8. Let's go to question 8. Question 8. Question 8 tunaweza songesha kidogo like that. Question 8. The scheme below shows the energy changes that take place. Study it and answer the question. There is water solid, DH1, water liquid, then water gas. And the question is, what name is given to the energy of DH1? So we can first of all name the processes. The first one is from solid to liquid. That is fusion. Then 2 is vaporization. 3 is condensation. Hiyo ya chini 4 is freezing. To answer the other question that is down there, from solid to gas, from solid to liquid, that is endothermic. From liquid to gas, it is also endothermic. Then 3 is exothermic, and 4 is exothermic. If you look at 2 and 1 and 2, those ones we can talk of a heating curve. When you are heating, the heating curve, heat is absorbed. From solid to liquid to weaken the intermolecular forces of attraction. Then from liquid to gas, heat is absorbed to help in breaking the bond. That is bond breakage. From liquid to gas, bond breakage. Bond breakage is an endothermic reaction. Then for the cooling curve, now where we start from gas to liquid, that is 3, DH3, that is heat is being lost because the bonds are being formed. The gaseous particles are coming close together to form a liquid. So that is the exothermic reaction where heat is being lost. Then from liquid to solid, heat is further lost. So that one is also an exothermic reaction. So by the time we are forming a solid, we already have now the bonds have been formed. So that one is also exothermic. We move to the next question. Hiyo swali ingine iko hapo chini, tuendelee. The next question. The next question. Have reminded ourselves of the bond breakage and bond formation. So when there is bond breakage requires heat, that is an endothermic reaction. We move now to the next question. The next question. That is down there. What is the sign for DH3? For DH3, the sign is going to be negative. Reason, heat is being lost to move from gas to liquid. Both are being formed. So in that case, the sign is negative. The sign is negative to show exothermic reaction. Now we are in the other question 9. That question 9 is on the rate of reaction. It is also a question on rate of reaction, but basically we can be able to answer it. We can be able to answer the question. The table below gives 3 experiments on the reaction of excess hydrochloric acid, 1.8 grams of zinc, and different conditions. In each of the volume, the gas was recorded in different times, intervals. What is constant? The zinc, the mass of the zinc is the same. What is different is the amount, because concentration is the amount. The amount for 1 is 1 molar. For 2, it is 1 molar also, and for 3, it is 2 molar. So the amounts are different. On the amount of the acid are different, but the amount of the zinc is the same. Another thing that is different is the surface area or the size of the particles. In a normal reaction, if the particles are small, the reaction will be faster because more of the surface area is exposed, as opposed to if you are reacting large particles. In terms of amount, if you have got more amount reacting the same, taking place in a reaction, I give a simple reaction. If you have got a small piece of metal, like sodium, you put it in water. And another case, you have got a very large piece of potassium, you put it in water, definitely. The two reactions will not happen at the same rate. The one where there is the large piece, the reaction will be very, very explosive. So when you increase the amount, you increase the rate of reaction. Kwa hivyo tukichora hizo curves that are down there, the steepest is going to be Roman number 3 because the amount is high and the particles are very small. It is going to be followed by which one? It will be followed by Roman number 1. Roman number 1 will react faster than Roman number 2 because the amount of the acid is the same, but in Roman number 1, the particles are smaller. So the rate of the in 1 than in 2. So if you are to draw in the steepness, the one that will be very steep will be 3. Then followed by 1 will be steeper, but not like 3. Then the one that will be less steep will be Roman number 2. So that question is testing on the factors that affect the rate of the reaction. Something else that we are going to go through when we'll be looking on the topic. But for now, that is at least the one that I just wanted to highlight on that, but you'll still come across it in the topic, rate of reaction. Tuendelee hiyo swali ingine. We continue with the question below there. I have said on the how to draw, the one that is the rate has got the highest rate will be the most steep, will be the most steep. So itakuwa 3, then 1, then 2. Lakini pahali sinamalizia pale mwisho tunashikanisha, because the reaction will have to come to an end at a particular time. We proceed. Hiyo swali ingine hatuwezi fanya, so tuende hiyo ingine. We move to the question down there. Next, that will be yeah, we can answer that one. That one we can answer. Number 11 is a question on a calculation where we have 3 isotopes. Isotope 39, isotopes of potassium. And we are given the RAM is 39.5. So how do we answer that question? To calculate the relative atomic mass, take the mass number of the first isotope, which is 39, times its relative percentage abundance, plus the mass number 40 times its relative percentage abundance, plus mass number of the other isotope 38, times its relative percentage abundance. And because we are given the one for 38, so that one we are going to say 38 times 0.01%. And it is equals to 39.5. The other percentage abundances will be 100 minus 0.01, which is 99.99. So the total for the other two, that is 39 and 40, would be 99.99. And so 1 will be x, E39 tuseme ndio x. Then 40 tuseme ni 99.99 minus x. So that our equation will be 39 times x plus 40 times 99.99 minus x plus 38 times 0.01 divided by 100 is equals to 39.5. That is the way to go about that question, because we are already given one. So you work out that question. Sasa hii itakuwa assignment. I repeat, 39 times x, you bracket, plus 40 times 99.99 times, 99.99 minus x, plus 38 times 0.01, all of 100, all of them you divide by 100 is equals to 39.5. That one you will calculate. If you calculate and get the answer before we finish, it's fine. That is assignment. That will be assignment that you can work out on your own. That will be the only assignment that I will give. Number 12. I'm on number 12. A green solid D was heated until there was no further change. The following observations were made. A colorless liquid condensed on the cooler part of the test tube. Then a brown residue S was left. Then next, give the identity of the solid. A colorless gas which changes acidified potassium dichromate 6 to green was formed. So from Roman number 2, we can already tell that what was heated is definitely would be a sulfite. Because when you decompose a sulfite, when a sulfite is decomposed, it will give SO2, or rather sulfur 4 oxide. And the sulfur 4 oxide is the one that is responsible for changing acidified potassium dichromate 6 to green. So, and then a brown residue was formed. That brown residue is going to help us to know the cation. So that cation can only be iron. The cation there is iron. Then what is heated there can be a sulfate. A sulfate that will decompose to form sulfur 6 oxide and sulfur 4 oxide. So in that case, the salt is iron 2 sulfate. And we know that iron 2 sulfate is green. Iron 2 ions are green. So iron 2 sulfate is green. We have said it is iron 2 because it is green. We have said it is a sulfate because when this sulfate of iron 2 is decomposed, it gives two gases, sulfur 4 oxide and sulfur 6 oxide. And the sulfur 4 oxide is the one that will be responsible for changing the dichromate 6 from orange to dichromate 3, which are green. Give the identity of solid D, iron 2 sulfate. The equation: iron 2 sulfate, an arrow, iron 3 oxide, sulfur 4 oxide, and sulfur 6 oxide. How do you chemically test for the colorless liquid? The salt is hydrated, and so it has given out water. The colorless liquid is water. It is tested by putting anhydrous copper 2 sulfate, which will change from white to blue. Another way is by putting anhydrous cobalt 2 chloride, which is blue, and when the liquid is put, it will change to pink. Those are the two chemical tests. The residue S is iron 3 oxide. Iron 3 oxide. Residue S is iron 3 oxide. Because I have said iron 2 sulfate decomposes to give iron 3 oxide, SO2 and SO3. So S is iron 3 oxide. I want to end the lesson because I have seen quite a number of the students are saying goodbye to the teacher. So I also say goodbye. Go through the other questions that are remaining. And for the few days that are remaining, keep on learning.